Hey guys, it's Miss Johnson here, and today I am going to bring you your video for our statistics and graph notes. Um, we're doing some statistics and graph notes and worksheet together in one little packet, which is why you have a couple pages stapled together. And we're just going to look at the first couple examples together in this video. So up at the top of the first page, it talks about stem and leaf plots. Stem and leaf plot. What is a stem and leaf plot? Stem and leaf plot is a quick way to organize large amounts of data, and you can look at um, different categories and how many data points fall under each category. So here's the steps to creating the stem and leaf plot. The first one would be find the largest and the smallest number and identify the greatest place value. So figure out where the smallest number is, figure out where the largest number is in your list, because a lot of times this data isn't listed in order, so we have to find them throughout the list. Then we have to figure out the place value as well. We draw a vertical line to list the stems and the leaves. The greatest place value is going to be on the left, whatever the greatest place value is. A lot of times that's tens and ones. Sometimes it's ones and tenths place, if there's a decimal point in there. It just depends on what kind of data you're given. Then the next one, number 3, is fill in the leaves on the right with the corresponding stem. You arrange them in order. So we're going to list that data in order from least to greatest. And then we also have to create a key. We got to tell them what the stems and the leaves mean. So if you look at the information that was given to you, this is the data that you were given. And here you can see where it's not listed in order, 165, 78, 83, and so on. It goes up and down and bounces around. So we'd have to go through and find the greatest and the least, decide on the stems. In this case, they used tens and ones, and you can see that with the 6, the 7, the 8, the 9, and the 10 that are listed. And then the leaves fall behind it. And you can also see that the leaves are listed in order there. So just looking at this stem and leaf plot right here, this is our stem and leaf plot. This guy right here. Ooh. You can see that we have quite a bit of data in the 7s, 8s, and 9s even, and not a whole lot of data in the 6s and the 10s. But it's just a quick way to see. And then, of course, we have our key down at the bottom. The 7 and the 1 means 71. Okay. So let's take a look at number 1. It says create a stem and leaf plot for the weekly babysitting earnings. It says drag the digits from the box to make a stem and leaf plot. So we want to first decide our we need to figure out what our lowest and our highest data point is. If I look through my list just quickly, 52, 49, 37, 21, 65, 23, 49, 51. I see a couple of 21s. It looks like that might be my lowest. And, ooh, I see a 61. Oh, I see a 65. I think that one might be my greatest. So I'm going to make my stems and my leaves the tens place. So I'm going to split them like that. So then I know that 2 is going to be my smallest stem, and I know that I'm going to have stems going up from there. So 3, 4, 5, and 6. And then I need to list the data points that fall under each one. So under 2, here's a 21, here's a 21, a 22, a 24, a 23. I think those are all my 20s. So let's drag those out. I have a 21. I have another 21. I have a 22. I have a 23. And I have a 24. So I should have 1, 2, 3, 4, 5 data points there, and I do. 1, 2, 3, 4, 5. So let's look at the 30s. In the 30s, here's a 37. That green's kind of hard to see. That's my only 30, looks like. So I just need a 37 there. So I'm going to drag a 7 out for my, oops, hello. Drag a 7 out for my 37. There it is. And then, actually, I should probably slide these up a little bit. There we go. Then the 40s, if I look at the 40s, in the 40s I have a 49, I have a 47, a 44, another 49. So 4 data points there. 44 is my lowest, it looks like. Then 47 and 2 49s. Oops, there's another 49. You're in the wrong spot. Go back. And the fives, for the fives, I have a 52 right in front, and a 51, and a 53, and we're almost done here. So 51, that's a 0. I want the 1. There we go. 52, and 53. That's what I think I saw. And then the last but not least, I have a 61, and I can't forget about that 65 that I already had underlined before. So 61 and 65. So that's what our 7-leaf plot should look like. We can see that there's a lot of data in the 20s actually, and then quite a bit in the 40s as well. So those seem to be the common earnings. And here's what our stem and leaf plot should look like. And it does. There we go. Okay. Let's take a look at the next one, box and whisker plot. So for a box and whisker plot, there is a lot of data that we need to find in a box and whisker plot, and making um, the box and whisker plot with this data is a little challenging, but a box and whisker plot seems kind of hard for some people to make. But there's quite a few data points that we need to find, and then we put them all in a number line. So it's another way to gather and interpret a set of data. The great thing about a box and whisker plot is it kind of splits it into 4 equal regions. So you get 25% of the data in each region of the box and whisker plot. So that's a kind of nice way to look at it, and you can see quick small glances of it that way. So, first thing. Okay, first let's just go through and talk about what each of these words mean. The lower extreme is the lowest value, or in other words, the minimum. So this one is going to be minimum or lowest value. The upper extreme is the maximum or greatest value. The median is the middle of the data. And that's when the data is in order. So we have to make sure our data is in order first. The lower quartile is the median of the lower half. And the upper quartile is the median of the upper half. And that's not including the median of the whole set. So we'll talk about that on the next page. The interquartile range is the range from the lower quartile to the upper quartile. And the overall range is the range or difference from the lower extreme to the upper extreme. Outliers are points that are more than 1.5 times the interquartile range. 1.5 times IQR away from the top. The mean is the sum of values divided by the values. And we are used to calculating means. We do that a lot. And the mode is the data points that appear the most. Most often, mode and most kind of go together. So let's just take a look at the example data that we are given. We're looking at the lengths of 13 fish caught on Lake Minnetonka on August 15th. We're going to create a box and whisker plot. So the very first thing that I need to do is I need to list my data in order. If I look for my data and put it in order from least to greatest, it would look like this: 5, 6, 8, 9, 9, 12, 12, and 12. There's 3 12s there. And then a 13, 14, 14, 16, and 20. So there are my data points listed in order. And then I want to go through and find all of these things. So the lower extreme is going to be that one, 5. The upper extreme is going to be that one, 20. The median is the one in the middle. Now, usually the easiest way to find the median is just to kind of cross off from first to last. So then 6 and 16, 8 and 14, 14 and 9, 9 and 13, 12 and 12, and it'd be this 12 right here. The lower quartile, I need to look at just the lower half and find the median of that. 5, 12, 6, 9, 8, and 9. So it's between 8 and 9, which would be 8.5. And the upper quartile, again, I don't include the median in those. And that's going to be between 14 and 14, which is still 14. The interquartile range is the range from the upper quartile to the lower quartile. And when I subtract those two, 14 minus 8.5 is 5.5. And then any outliers, in this case, there are none because 20 is not going to be more than 1.5 times away from the last one. 20 is only 4 points away, and the interquartile range is 5.5. So I'm already within that, even before multiplying it by 1.5. And then, so, oh, I skipped the range, sorry. The range overall is 20 minus 5, which is 15. The outliers were none. The mean, when I add them up and divide, I get a mean of 11.5. And the mode, the one that I see the most, I see 312, so my mode would be 12. So then let's go ahead and put that on a number line. So I'm going to draw a number line. I'm going to start down at 5. That's my lowest point, and I'm just going to count up. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And it'd probably be good if I marked some more points in there. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There we go. That'll work. And then I do my box and whisker plot right on right above the data. So I should actually move all of this down a little bit maybe. Give myself a little more room. Sorry if you had to erase on that one. But I like to do it right above so I can kind of see the number line in addition to the box and whisker plot. So the first thing, my lower extreme is going to be at 5. My lower quartile, the next one would be 8.5. That's 6, 7, 8.5 right in between the 8 and the 9. Then my median is 12. The upper extreme is 14. And then the upper quartile was 14, and then the upper extreme is 20. The middle 3 points make the box, like that. And the outside points make the whiskers. So there's the box and there's the whiskers. All right, so there's our box and whisker plot. Okay, we're going to go ahead and stop our video for today at that point. Thanks for watching, and we will come back tomorrow and talk some more. Have a good night.